Alright, so we're getting into Unit 2 now. And Unit 2 talks a lot about rational numbers and irrational numbers, and it starts with square values and exponents specifically. And up till now, well, maybe not earlier, but up to now we've just really been talking about adding and subtracting and multiplying and division. And those are four different mathematical functions, right? You had a 1 plus like a 1, and it ended up equaling like two things like that, a 1 and a 2. And then you had like a maybe like a 2 things like that minus a 1 thing, and it ended up equaling a 1 thing, kind of like that, right? So, and then if multiplication was a little bit higher math, right? We had a like a 2 things like this, a group of 2 things, and then we multiplied it by another group of 2 things, right? And then we ended up with 4 things. 1, 2, 3. Well, maybe just do it times 3 things, and then we ended up with 6 things, like that, right? So you can see it was a little bit higher math because it's it's 2 times 3, and if we had like 6 things, we'll do 8 things. And we divided it by into 2 groups. Well, each one of those, 1, 2, 3, 4, would ended up being just four groups. That'd be 4 groups. 1, 2, 3, 4. Well, maybe it'd be better represented to be like this. Better represented to be 1, 2, 3, 4. So anyway, so these are different. These are pretty simple lowest level functions: addition, subtraction, multiplication. Mostly shown as this, right? Sometimes shown as just a dot, and then division, sometimes shown as like just that, as an A over a B or something like that, right? As a fraction. But now we're getting into exponents, where we have a base, raised to an exponent. Call this like the m or whatever. Don't use e because e is a special number. Okay, so base raised to an exponent. What does this mean? Well, this means that we have in the lowest level exponent, which is 1, I guess. We're not going to talk about 0 for right now, but it's 1. But this is what you've been doing your entire life with numbers, because anything raised to itself is just itself. Like 3 to the first is just 3, right? So you just don't write the 1. It's invisible. You just don't write it because it would be redundant to do so, but it's there. It's just invisible. Okay. Right, so you don't bother writing it, but just know that it's there and it's invisible. Kind of like when you write a 1 in front of a B or an X, you know that there's a 1 there, right? But it's invisible. You don't really need to write it because it's invisible. Okay, and that's multiplication there. But just know that there's a 1 exponent on top of anything, because anything raised to its first is 1. But what we're going to talk about is the first one. What happens if we change this to the next number up, which is 2, and that is called a squared. Okay, 2 to the an exponent, a number, a base raised to 2 is called a squared. Well, why is it called a squared? Okay, well, that's pretty simple. Well, if we have, say we have 1 raised to the 2, 1 raised to the 2, well, this just equals 1. Because if I have 1 this way and I have 1 this way, I have one block. Well, that's pretty boring. Well, it gets a little bit more interesting when we have something like a 2 raised to a 2. What this means is it's 2 times itself. 2. Okay, so a 2 squared, when you raise something to an exponent, you're multiplying that base times itself to the number of exponents, right? So this is the base times itself 2 times. Okay, so I'm going to multiply this thing. 1 times 1, sorry, 2 times 1 is itself, but I'm going to do 2 times 2. 2 times 2 is going to be equal to 4. Right, so I have 2 times 2 this way, 2 times 2 this way. So I have 1, 2, 1, 2, and I have 4 total. Okay, so that's 2 squared. Hey, look, I have a square. Okay, so 2 squared is 2 times 2, which ends up being 4. Okay, and I have a perfect square. All right, next, let's see if I had a 3 squared. All right, well, I'm going to go 3 one way, 3 the other way, and fill in everything. So 3 times 3, so I have 3 times. 3 times, and I have 1, 2, 3, I have 9. This equals 9. Oops, 3 times, 3 squared, 3 times 3 equals 9. Okay, this equaled 4. This equaled 9. Okay, say if I had 4 squared, I have 1, 2, 3, 4, and 1, 2, 3, 4. 4 that way, 4 that way. Fill it in. Either way you look at it, I have 4 rows of 4 or 4 rows of 4. I have 4 times 4. 4 times 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or 16, because 4 times 4 is 16. It's a perfect square. Perfect square. And it continues. 5 squared. 5 times 5. And that would be 5 this way. 1, 2, 3, 4, 5. 5 this way. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so if I can, 5 rows of 5 makes a perfect square of 25. Right? So look at, these are all perfect squares, and this pattern would continue, you know, infinitely, right? Because I can square any number, right? And these, so these are all called, these numbers here, 4, 9, 16, 25, these are all called perfect squares. Those are all called perfect squares, right? Because I could take, well, we'll talk about square roots another day, right? But these are all called perfect squares, right? So you can just do, you can make a table, right? You can be like, okay, this is n, okay? Well, we'll call this b. We're going to call this b. This is my base, right? My base, and then I make, this is n, okay? So my base is this, and n is this. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. My base is 1, and if my n, so this is my n value, and this is my b value. This is b, and this is n. Okay, so yeah, we'll do that. Yeah, so this is my b value. Let's do this one. Yeah, so this is b, and n is 2. N equals 2. Okay, so b, this is b, and n equals 2. All right, so if n is 2, let's do this then. We'll do this. Make it easier like this. This is b2. This is b squared. There we go. There we go. This is b squared. So 1 times 1 is 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 times 6 is 36, also known as 6 squared. 7 squared is 49. 8 squared is 64. And 9 squared is 81. Okay, so if we were to draw something like this, you know, like, okay, 1 is 1, 2 is 4, 3 is 9, 4 is like 16, 5 is like 25, 6 is like 36, 7 is like 49, right? So it looks like a kind of like a curve like this, kind of like does this, okay? But what happens if I do b is -1, -2, -3, -4, -5, -6, -7, -8, and -9? Well, something interesting happens. What's -1 times -1? Well, remember, if I have a negative squared, that's a negative times a negative, that's going to equal positive, right? So anytime I raise a number to a squared, I square a negative number, or I just raise it to an even number, my result's always going to be positive, right? So the numbers are going to be the same, right? So this is going to look something very similar, like that. So it's impossible to square a negative number and get a negative value, right? Cannot square a negative number and get a negative value. Value, V-A-L-U-E, that's too many value, right? So that is the gist of square numbers, okay? That's an really important mathematical concept, right? Not in the real world, right? In the complex world, that's way beyond what we're teaching now, but in the real world, we cannot square a negative number and get a negative value, because a negative times a negative is positive. Okay, common mistake here is that when people square this, right, they think, well, this is just 2 times 2, right? So when they go to this, they'll be like, oh, this is just 4 times 2. That's wrong. This is 4 times 4. Okay, this indicates the number of times. The exponent indicates the number of times you multiply this number by itself. The number of times you indicate this number, the base, by itself. That is the exponent. In this case, this is squaring. I hope this helps out.